Good afternoon. Thank you for joining us on this Metro Tunnel Live event hosted through Facebook. I will be putting some questions to Paul Thomas, the Metro Tunnel's tunnelling guru. How many tunnels can I get in one sentence? Paul is Rail Project Victoria's Deputy Director of Tunnels and Stations. And today we're just going to be having a bit of a chat about the progress that's being made on the Metro Tunnel, Victoria's biggest ever public transport infrastructure project. My name is Ian Gilbert. I'm from the media team, but the star of today is Paul Thomas. I hope you like the music for the intro there, Paul, because you are a bit of a tunnelling rock star. First up, we're just going to get a bit of an introduction from Paul. You've done a fair bit in your career. Just give us a couple of lines about what you do on the Metro Tunnel and how you've got to that point with your career so far. Over to you, Paul.
Thank you, and thank you for the introduction, and good afternoon and welcome to everybody. So, yeah, Paul Thomas, Deputy Director. So I'm originally from South Wales in the UK. I studied civil engineering at the Polytechnic of Wales. And I've spent the last 30 years in civil engineering, mainly in the tunnelling and underground space. And that's included similar projects, just like what we're delivering here in Melbourne, in New Delhi, in Singapore, in Hong Kong and in Riyadh. So I've been a blasting engineer, a piling engineer, and I've also done quite a bit of tunneling as well. So yeah, I've had a fair amount of experience there.
Excellent. Now, a reminder for people joining us, the aim of today is to pose your questions to Paul. Anything you want to know about tunnelling and the Metro Tunnel, the process, how those big tunnel boring machines, our Tbms, are creating those twin 9-kilometre tunnels across Melbourne, please fire away, post your questions on our comments piece, and away we go. Now, the reason we're doing today's event is because we have had a couple of breakthroughs on the project in recent weeks. We have had a great breakthrough at our eastern tunnel entrance at South Yarra, where Tbm, remember that's tunnel boring machine, Tbm Millie broke through the other day, and then Tbm Meg broke through at Parkville. And those two events have helped us to notch up 50% of tunnelling completed so far. And so that's why we've decided to go live, do this Facebook Live event for the Metro Tunnel with Paul Thomas fielding your questions. So a quick reminder there, post your questions in the comments field on our Facebook page, and we will endeavour to answer as many as we can in the next 45 minutes or so. So Paul, we've got some great footage of these breakthroughs that I've just mentioned, and we're going to try and share that with the viewers. And it'd be great if you could just talk us through what's happening here. This is the South Yarra breakthrough with Tbm Millie, named after Millie Peacock, the first female MP in the Victorian Parliament. So tell us what's happening here.
So yeah, we can see the Tbm breaking through at the eastern portal down at South Yarra, and what you can see in front of you here is a bit of a time lapse. But then you can see that the liquid coming from what we call a stub tunnel. The stub tunnel is basically a reception chamber to allow the Tbm to come through in a safe and controlled manner. Also at South Yarra, we got some shallow ground and a bit of a mixed ground condition. So this provides some additional support to the surrounding infrastructure. You can see at the top of the stub tunnel some round tubes, which we call canopy tubes, provides an umbrella support, again, to help provide some initial support to the excavation. So the picture that you can see now, that's the cutter head rotating at probably 4 revolutions per minute as it breaks through, probably pushing at a force of about 1,000 tons to 1,500 tons, and basically coming through the board pile wall that's there, the retaining wall, and then breaking through a shotcrete layer, which provides the shell to the reception chamber. That's not the speed of the cutter head you can see there. That's been speeded up a little bit. So that's the true rotation speed that you can see there.
Paul, I'm just going to jump in there. Paul, tell us what it's like when you're actually down the shaft looking at one of these things. You know, is it incredibly noisy? Is it hot? You know, is the steam coming off the Tbm?
Not quite like that, Ian. It's a controlled environment. So again, you probably notice in the shaft there's lots of pipe work within the shaft. So again, that provides ventilation for the crews working within the shaft. There's plenty of light in, so the atmospheric conditions are quite favorable. Obviously, there's a bit of liquid you can see there, which is the slurry fluid that's used in a slurry machine that comes through. These are pressurized machines, but the pressure is lowered as you break through. And of course, as it's cutting through concrete piles and shotcrete, there is some noise associated with that, and there's some vibration associated with that as well. But nothing untoward that's really noticeable. So this will be the key point you can see in the picture here, just as it starts to push through. And the crews give that TBM the final push just as the shotcrete comes down, and so that gets it's a bit like ice cracking. Once you've got the ice starting to crack, the rest follows on with a lesser effort, so to speak.
Okay, now Paul, I think I might just try and stop the video there, because we're starting to get plenty of questions coming through, and we can come back to some of that footage. I'm going to tie two questions up here. What's the biggest challenge that's faced on the metro tunnel with the tunnelling? And that's from Brendan Elliott. And then we have another one from Damien Coop. Has there been any blasting needed on this project, or is it all done with road headers and TBMs?
Two very good questions. So in answer to the first question, I think Brendan might have been asking this question. There's significant challenges on a day-to-day basis. The success of this project, of course, it involves the TBMs, it involves road headers, but it involves logistics. You know, this is a logistical challenge. It's a wide geographical spread of the project, 9 kilometers end to end, 5 stations. So, you know, the logistics and the support involved in servicing the works is very, very important, considering we're in the CBDs and other urban conurbations. The second challenge is obviously ground conditions. Here in Melbourne, we do face variable ground conditions, and I think down at the Yarra River is probably the more challenging of ground conditions, as we tunnel underneath the Yarra River and Princes Bridge, which is the last of our tunnel drives. And here under the river, in approximately 550 meters of the last tunneling drives, we probably encounter about 7 different geotechnical interfaces. Interfaces meaning it comprises of softer soils, hard rocks, boulder material, sandy material. So it's a true geotechnical challenge to tunnel underneath the Princes Bridge. But I would add, all very well thought out, all very well designed, and all very well planned. So we're quite confident of getting through this geotechnical challenge.
Excellent. Okay, I've got one here that could be quite.
Question was about blasting.
Sorry, Paul.
To answer the second question.
Yes.
No, we're not actually blasting on the project, even though we do encounter some very hard rock locations where some of the rock strengths can be in excess of 100 MPa, which is about 2.5–3 times of the concrete. We're not going to do any blasting. We're going to rely on mechanical means and methods such as hydraulic breakers, road headers and such to remove that hard material.
Okay. Here's one that I think is probably quite a quick answer. This is from, we've got some younger viewers today. This Excellent. Is from Oliver Tan, aged 5. Okay,
right.
I think he's posting through one of his parents' Facebooks. What is the maximum speed of a TBM?
Excellent question, Oliver. So look, the TBM speed, or advance rate as we quite often refer it to, depends on geological conditions amongst other things. Here in Melbourne, with the Melbourne Formation, it's a sandstone material. Our TBMs at the moment can achieve anything from 10 to 15 meters per day, depending on the geological conditions and other factors such as maintenance. So again, it might sound slow, but in the overall scheme of things, that is very, very good progress.
Okay, so that was 10 meters per day, roughly, which I think also answers David Bidwell's question. It's an excellent question here from Gary Buck. Do the TBMs change directions, the cutter heads, clockwise or counterclockwise? And by the way, the cutter head is that thing you can see behind me on this virtual background for the viewers. The cutter head is the business end. So do they go clockwise and anti-clockwise?
They can be bidirectional, that's correct, yeah. So both ways the TBM head can rotate.
And is there a reason for that, to stop them getting, stuck or something like that?
There's various reasons. One is to make sure that that's even in terms of cutting. You can see behind you the cutter wheels are not in your picture behind, but it does offer the cutter wheels to rotate in different directions, which helps with wear and tear also.
Okay, excellent. Now, a question from Brian Lewis. How consistent has the geology been? You touched on that just now. but you might want to elaborate on that, particularly the Melbourne formation, for those who aren't familiar with such a thing. So from Brian Lewis, how consistent has the geology been, and found anything unexpected?
Oh, excellent question. So look, I'm pleased to say that we haven't really found anything unexpected yet, just bearing in mind that we're only 50% of the way through. And what's been really encouraging from my point of view is that the very early geotechnical investigation works we done, meaning that we put some vertical drills in the ground at periodic spacings and checked the ground conditions along the alignment. And in particular, we were very interested in the Melbourne formation near the Yarra River, where we expected to find some fault and dike zones. In other words, areas that would be comprised of softer and more permeable material where water might have been a problem. So what we've actually discovered, and this is in the context of the caverns in both CBD North and CBD South, is that the joints and the faults that we predicted, we've actually encountered. So tick the box, we found them. But the good news story is they were not quite as bad as what we expected them to be. In other words, we thought they would be a much poorer geotechnical matrix. We thought they might be more weathered, but as a matter of fact, they've been more cohesive, so to speak. It's been a much tighter matrix, which has meant that from a ground support point of view and from an excavation point of view, that's been more favorable for us.
Okay, and Paul, we've got some footage here. You might be able to talk us through what we're seeing here in one of the caverns.
Yep, so that's good timing. So we are underground here at one of the CBD caverns. I think this is actually CBD North. And we can see in the picture here at the back, there's a shaft. This is actually at CBD South, sorry. So this is the road header here, and these weigh about 100 ton plus, and that's what we use for the excavation works. You can see the rock bolting rig there. And again, in the background, you can see excavators, again, another rock bolting rig. There's the cutter head on the road header there, which actually cuts and mills away at the rock. And you can see the arch profiles there of the caverns and the adit. So this is the central part. This is actually an adit going towards Federation Square and underneath Swanson Street and Flinders Street. So again, yeah, sorry, Ian, go on.
No, so to clarify, the road headers are being used for those caverns, those station caverns.
That's right.
In the CBD for what will be State Library Station and Town Hall Station.
That's correct, Ian, yes.
And then the Tbms for our twin 9-kilometre tunnels. And we've had a great question from Denzel Whitfield. What will we do with the Tbms when they're finished?
Oh yes, good question. So look, with the Tbms, nowadays there's obviously a great deal of focus on sustainability and reuse, which is obviously a very good thing. So in the case of metro tunnels, and if you look at the picture behind Ian, the white steel rings there are what we refer to as the Tbm Shield. So all the workings of the Tbms are contained within those shields there. When the Tbms arrive and conclude their excavation works at the CBD station, CBD South, Town Hall area, the shields themselves are left in, and we call these sacrificial shields, and they stay in place, and eventually they are cast in concrete and forms part of the permanent works ultimately. But the other components, such as the cutter head, the cutter wheels, and all the hydraulic motors, for instance, the segment erector, the refuge chambers that are on the Tbms, these are more likely to get repurposed and reused on other Tbms. So our supplier Herring Connect has a very good strategy in place to reuse and refurbish as much of the material as possible. So they do buy back a lot of these elements.
Excellent, excellent. Now, I think we've got some good footage of one of our Tbms breaking through at Kensington, where we had to break through into a water chamber. We'll try and get that footage up while we just answer a couple more of these questions, because we're sort of sticking with the Tbm and the business end of Tbms at the moment. Simon Mullins asks, do those cutter heads need sharpening after a run?
No, the cutter heads don't, but the cutter tools, and again, we refer to them as cutter rings, they do get regularly replaced. So it's a bit like, I suppose, wheels on a car. They get put in different locations. And if you can see the picture here, you can see the cutter rings there, which are square shaped, and they got the rings there. So these tools can be replaced, and they are replaced. They're taken out from the back of the cutter head within the shield, and the cutter rings and the cutter bearings do often get replaced depending on wear and tear, but the cutter head itself generally is okay. Once it's achieved a breakthrough, obviously there's an inspection, and if any what we call hard facing is required to the cutter head itself to patch up any areas, so to speak, then that maintenance is undertaken.
And can you explain to us why that TBM was coming through into a water shaft that we can see here, water-filled shaft?
Yeah, good question, Ian. So if we just cast our minds back to about 10 minutes ago, where we saw the eastern portal shaft, which was a dry area or a dry shaft, no water in the shaft. There's two differences between the western portal and the eastern portal. Here we are very close to obviously existing rail infrastructure, and there's also some services close to this shaft. Normally, instead of filling a shaft with water, you can provide ground treatment to the external of the shaft. So you provide a ground treated zone, so to speak, for the TBM to dock into, and then finally breaking into a shaft. And that means that the ground and the groundwater table is not compromised outside the shaft. However, in the case of the western portal shaft, due to space areas, there wasn't an opportunity to perform ground treatment. So in order to maintain the equilibrium of the groundwater outside, we fill the shaft full of water, so it maintains the balance. If the groundwater was to be drawn down, that could have ended up in some surface settlement, which we don't really want. So again, it's balancing the groundwater levels in this area to a great deal of success.
All right, we've got another question. What are the cutter heads made of? Diamonds? Presumably it's got to be something pretty hard.
Yeah, no, it's Heron Connect, our supplier, generally keeps this a secret in terms of what the composition is, but I've been fortunate enough to visit Heron Connect's factory in Schwanner in Germany, and where they make the bearings and where they make the cutter heads. So again, it's a very, very hard, robust material, and certainly can stand the wear and tear of very hard rock conditions, as well as the cutter tools. The composition of the cutter tools is very, very important.
But it's a trade secret, right? So there's your answer.
It's a trade secret, yeah.
So I think we've got some more TBM footage, because it seems like we've got a lot of interest in the actual, the business end of these TBMs. So we might be able to try and get up some footage of TBM Meg breaking through at Parkville. Parkville is obviously a very important, well, they're all five are very important stations for us, but Parkville obviously opens up that whole medicine and education and research precinct when the metro tunnel finishes in 2025. So a lot of focus on Parkville. Paul, tell us what's happening at this one.
So again, what we can see here is a breakthrough that's similar to the Eastern Portal, except we don't have any reception chamber. It's not required. Parkville itself and the surrounding environment has got very good rock conditions. We don't have any prevailing groundwater issues, meaning that we can allow the groundwater to drain in, so to speak, because there's no softer compressible material at the surface. And you can see here that that's a good shot, because you can just see the TBM breaking through the board piles, which we use to form the outside of the box. And that is not steel reinforcement, that is glass fiber reinforcement. The reason we use glass fiber reinforcement is that the steel could cause damage to the cutter head and the slurry pumps. So with glass fiber, it's easily cut and chomped away, so to speak. The yellow steel section you can see there is akin to strutting. That provides lateral restraint against the head wall, the bank wall there, because the TBM at this stage is pushing quite hard to get through and cut through the board piles and the shotcrete there. Again, probably pushing at about 1,500 to 2,000 tons. So there's a lot of force, a lot of energy being applied here to break through the wall.
Could you compare that to anything? The force you're talking about, can you put that into layman's terms?
Maybe trying to, well, trying to pull or push a couple of 747.
I'll put you on the spot there.
You called me out.
Now, how often do the cutter heads need to be changed? Asks Brendan Elliott.
The cutter heads themselves don't have to be changed unless there is a major problem. during the tunneling works, which is a low risk. But again, as I said, the cutter tools themselves, as we've seen, that are affixed on the cutter head, the round turning tools get changed periodically at maintenance points. So again, that's the most common item that gets replaced and rechanged.
Okay. Now we've got a question about the tunnel itself as opposed to the tunnel boring machine. Ethan Rosario has asked, what carries the concrete tunnel lining in the TBM? So obviously those TBMs, they go through, they dig out the tunnel, but then they line the tunnel as they go to create the finished tunnel.
Correct.
How do those huge bits of concrete get out there?
Right, well, I might just, this is a good video, and I've also got a TBM model here I might refer to. But this is the tunnel here where obviously the segments have been installed and the TBMs have been taken away, and also all the TBM services have been taken away. So this is not quite the finished product. There's still cross passages and first stage concrete to be installed. But in order to get the segments to the TBM while it's building the tunnel, we use what is called MSVs, which are multi-service vehicles, which are rubber-tired vehicles. They can drive in and they can drive out. So there's drivers, cabs, front and rear of the MSVs, and they basically bring the segments up to the TBM. And if I refer to my little model here, so this model here is an EPB, it's not a slurry machine, but this is where the segments will be installed in this area. This is what we call the ring build area here. And if you can just see my model, there's some segments here which have been delivered. So the MSV would come up. There's a gantry crane then on the back of the TBMs, which actually then lift the segments which form the ring, bring them into the ring build area, and they moved along here by a gantry system into the segment ring build area here, where they'd install then within what we call the tail skin of the TBM. Then that full segment ring, once it's installed, the TBM then pushes off there and recommences the cycle. Okay,
excellent. Now we've had a few questions about cross passages. So I'm just saying that so our video Supremo can get that ready. Oh, there you go. Speak and it shall be done. Now, Paul, tell us about what a cross passage is. We're getting some questions about what exactly that is.
Okay, well, the cross passage, in very simple terms, connects both parallel tunnels together. And the purpose of the cross passages is obviously to provide emergency egress and access in the event, and this is during operational phase of the train, in the event that something occurs within the tunnel. If the train was to break down or passengers need to evacuate safely, they can be directed from the train onto a walkway to the nearest cross passage. Now, the cross passages here are spaced at every 244 meters. And also the cross passages, not only do they provide emergency access and egress, but they also house some of the key communications equipment required to operate the trains, such as telecommunication equipment. Some of the cross passages we have here, I think we've got 3 or 4 which have sump pits. So there's small pump stations, so to speak, within the cross passages. So we've got water running through. For instance, if there was a water ingress into the tunnel for whatever reason, the low point of the tunnel where the cross passage is has a deep sump pit, and that pump then will pump the water out of the tunnel. So there's a number of uses for the cross passage.
Got you. Our next question, I would say this viewer is very much an engineer. Alexander Ilievsky, how do you get the TBM precisely lined up with the recessed diameter in the Tympanium wall when they break through?
Oh, okay, that is a good question. So there is quite a sophisticated guidance system that used for the design tunnel alignment. And again, this is the TBM guidance system is controlled by automatic theodolite stations and laser beams, which helps it keep it on the true trajectory, both vertical and horizontal curves. And as each advance is achieved, there is a continuous monitoring in terms of the alignment of the TBM. Now, the TBM can waver every now and again, and I think we've got tolerances of plus or minus 50 millimeters. So this is a good shot. So you can see inside the control cabin, and that top screen there is where you can see the TBM operator can actually see real time how the TBM is actually advancing forward in terms of vertical and horizontal alignment. So again, he can control the alignment very accurately from within the control cabin. And there we are. That's I'm sure that's the guidance system there. Yep, where you can see the alignment of the TBM. And this is where you can see the vertical curve going through the geology there. So again, it's quite a precise way of control, very high degree of accuracy that's achieved in terms of the tunnel alignment.
And I should just point out, for those of us joining us on Facebook, some of the footage was captured well before coronavirus hit. So if you're wondering why some of those workers aren't wearing face masks or they're not socially distancing, it's pre-COVID times, and I can assure you that work is continuing on Metro Tunnel with all due regard to safety, and we've got all the correct procedures in place. So workers' health is obviously very, very paramount. So we're extending this for 15 minutes. Paul, I hope you weren't dashing off anywhere, because you're proving a very popular interviewee. And I'm going to give good old Oliver Tan, or rather young Oliver Tan, our 5-year-old, who's posing a couple through his parents' Facebook, start 'em young. He has asked, where do the TBM operators go to the loo?
Wow, what a question. But a good question at that. So the TBM itself is about 100 meters long. And again, I'll just refer to my model here. We've got what we call backup gantries here. And there's several of these on our TBMs underground at the moment. So again, about 100 meters. Right on the back of gantry number 7 is a toilet where the crew can go and use those facilities. The reason why it's at the back of the TBM, on the back of the gantry, there's a small crane that can help lift it in place and take it away, so that it's serviced properly, so that it can be clean at all possible times. So yes, we do have good welfare facilities underground. Excellent question, Oliver.
And thank you, Murphy, for jumping in with our excellent graphics there straight away. So just a reminder, thank you for joining us on this Facebook Live Metro Tunnel Q&A with Paul Thomas, our Tunnels and Stations Deputy Director. As I said, we're continuing a little bit longer to try and get as many questions in as possible. Please post your questions on the comments field. We'll get us through as many as we can. If we do overlook a couple, you will still get a reply. So make sure you post your questions. Our digital team will get back to you. And also, if you have any suggestions for perhaps an area of the Metro Tunnel project that you would like to see answered in a future Q&A, by all means, post your suggestions on there. We've got a question here from Wilson Wee. How does the working group communicate with each other in the tunnel? So I'm assuming Wilson means not just those TBM operators, but the people, back at home base, so to speak. So yeah, cool. How do they communicate?
So there's an extensive walkie-talkie radio system that's used. Again, quite sophisticated, which means that people underground and in some of the tighter spaces can communicate clearly to the surface. So all personnel there are armed with walkie-talkies. The operator in the control cabin there, the TBM, has telephone to the surface plus radio communication. So the communication system throughout the site is very modern, very state of the art. So communication, again, it's very good, very clear. Everybody's in touch with each other.
Right. And it's worth pointing out that, safety is obviously a huge thing with something like this, and a lot of thought and effort goes into making this as safe an environment as possible, Paul.
Yeah, that's correct. Safety, it goes without saying, safety is absolutely paramount in terms of what we do and how we deliver the project. And again, where credits due, the due diligence and the dedication of the workforce, particularly in terms of safety and making sure that the best practices are adopted, people do what they know they're supposed to do, is very good indeed, very good.
Which leads us nicely to the next question, the power of prayer. Who or what is St. Barbara, and what is the relevance to tunnelling?
So St. Barbara is the patron saint of tunnellers, and this is 4th of December is a very, very important day. The genesis of St. Barbara, or the folklore behind it, is that I think her father was killed by electrocution by a bolt of lightning back in the 4th century, and hence the reason why she became the patron saint for anything to do with ammunition, anything to do with armory and tunneling, explosives, blasting, and therefore she has become the adopted patron saint of tunneling and explosives and all things to do with underground mining and everything else.
So you mentioned explosives then. Obviously, tunneling was probably a fairly less safe kind of pursuit, you know, several centuries ago. And there's a question here from Rick Lee. How long have TBMs been used for such projects as the Metro Tunnel around the world? And how much impact have they had in delivering projects on time?
Massive impact. And again, that's an excellent question. So the history of the TBM goes back to London back in the 1850s, 1860s, where Brunel, I think, made the first sort of Tbm shield, so to speak, where it was compartmentalized, where there were little pockets where each of the individual workers would stand and actually excavate away at the tunnel face. And you know, tunneling, again, explosives, hard rock was used, but the history of the TBM has come leaps and bounds since the 60s and the 70s, where we rely more on sophisticated methods, particularly in softer ground conditions, to what we see now and what we use now, which are the slurry machines and the earth pressure balance machines, which allow us to have a much more greater degree of control on ground displacement, ground settlement, and groundwater behavior. So that means that we're not dealing with uncontrolled excavation phases. The groundwater and the ground can be controlled. So long as that's controlled, it means that everything above ground and in the immediate vicinity remains safe and stable. So again, you know, the modern day tunneling techniques are very safe. They're very efficient. Incidents around the world do occur, and unfortunately, I've been involved in a few incidents. Things can go wrong. But nowadays, with the technology, with the controls, again, it's a very safe, efficient method of tunneling.
Got you. Now, just for everybody watching, thank you for joining us on this Facebook Live Metro Tunnel Q&A with Paul Thomas, our Tunnels and Stations Deputy Director. We've got about 5 minutes left, so we're going to race through as many questions as we can. We don't get to everything, by all means, still post a question in the comment section. Our digital team will get round to you. Now, I've got a question here for you, Paul. Now, is there what's the most unusual challenge you've ever had on a tunneling job?
Okay, back about 20 years ago, after I'd finished one of the projects in Singapore, I used to work for a Japanese company called Kumagai Gumi. Anyway, cut a long story short, we were awarded a tunneling metro project in New Delhi, not too dissimilar to Melbourne Metro. We had 4 or 5 stations plus a depot line, hard rock, soft soils, quite similar in terms of challenges. So again, we had a lot of sensitive structure around the area, including universities, including elevated structures. But also we were tunneling and constructing stations close to the rock garden. Anybody familiar with New Delhi towards the north end of the city will know that there's a massive rock garden, trees, rocks and everything else, but monkeys live there, quite a lot of monkeys. And they can be a bit of a nuisance, but you know, culturally, they're very, very important. And they used to like to swim in our bentonite pools because the bentonite was cool while it's being mixed and within 40-degree temperatures. And so one morning I get a call from one of our staff to come quickly to one of the sites. Got there, and there were actually monkeys swimming in the bentonite pool to keep cool because it's much cooler. And he was worried about how to get the monkeys out of the bentonite pool without hurting them. And there's only one thing we could do, and then that was switch on the huge centrifugal pumps. And I can still visualize this to the days. Once the pumps started to operate, we had a vortex and the monkeys were spinning around in the bentonite pool. So we had to get a huge net and get them out. But the monkeys were a bit of a problem for us because they would also mess with the electrical infrastructure and quite often get electrocuted. Plus they would sit atop of the stations and decide to go to the toilet when people were underneath there. So that was one of the natural challenges we had in New Delhi.
I'm guessing there isn't an equivalent for Melbourne. I don't think you've got any sort of supercharged possums or anything to be found down in those.
Not quite. No, not
right.
quite.
Now, we're just into our last couple of minutes. We're going to try and race through as many questions that are left. So, Paul, pretty much one sentence answers. From Rosemary Renada, does it get hot underground?
No, there's a very good ventilation system which provides a very controlled environment. So temperatures are good.
Okay, I'm just going to see if Murphy, our video guy, can just get some footage up of the State Library, and we want to just talk to that a little bit. In the meantime, Ben Cole DeWitt, is there a predefined route for TBMs, or do you manually steer them?
No, there's a predefined route. So part of the guidance system involves the coordinates of the horizontal alignment being fed in, as well as the elevations for the vertical curve. So again, it's a predefined alignment. All the coordinates are calculated ahead and fed into the guidance system to make sure that the TBM stays on path.
Okay, we've had a question specific to State Library, and this is the State Library cavern that we're looking at now. Is there any impact on historical documents and collections underneath the State Library site?
Oh, I'm not aware of any at all. No, I think
because just to clarify for people, you're tunneling that far below. The whole point is to keep well away from, you know, structural foundations.
Yeah. So look, okay, I'll provide a bit of context there. So we positioned the underground cavern at CBD North and CBD South. So it's mainly under Swanson Street. But what we've done during design development and what CYP have done is we take into account the existing infrastructure, what the foundations are, and what's within the zone of influence, and we can actually run numerical modeling that will predict the behavior of any historical structures, buildings, or infrastructure. And we satisfy ourselves that these are okay. There's not going to be any compromise to the structural integrity. And as we construct the caverns, like what we can see here now, we heavily monitor the works, including all the concrete works you can see going on here, plus the cavern arch you see here where we've excavated. So in real time, we continue to monitor the behavior of the underground structure, as well as the above ground structures that are within the immediate vicinity of the works.
And it's worth pointing out that these are sort of engineering hurdles that are overcome in, you know, sites around the world. London Crossrail, Singapore, New Delhi Underground, hence bringing in people with experience like yourself.
But Ian, I will say one thing about the town hall and the State Library caverns. These are engineering marvels. There's not much of this work that's done throughout the world in terms of what we're seeing going on here. So for instance, that picture there shows the stub tunnels underneath the Merle. The Merle city loop connection there is just about 1 meter above the crown of those stub tunnels there. So the work that's being undertaken underground here, particularly with these mining caverns, is extraordinary. And again, it's an engineering marvel as far as I'm concerned. Fantastic work, and you won't see much of this around the world. This is very unique.
Yeah. I think we've just, we're going to have one more question. There's been a few along the lines of what actually drives the TBM cutter heads. What mechanism?
So they're electrically powered. There's 5 motors that are installed to what we call a main bearing. So the motors connect to the main bearing, electrically powered. I think the installed power is about 2,000 kilowatts of installed power. And then the cutter head is then connected to the main bearing. And so the motors turn within the main bearing, and that turns the cutter head, all electrically powered.
Great. And that question was from Dara Flannery and several others. Now we've got to 4:45, time to wrap up. Let me say thank you very much to everybody who joined us. Hopefully that was very informative and, dare I say, slightly entertaining way to spend 3/4 of an hour. Paul Thomas, Deputy Director of Tunnels and Stations on the Metro Tunnel for Rail Projects Victoria. Thank you very much for your time. It's always absolutely brilliant to listen to you and to those years of experience about, you know, these various huge infrastructure projects. But especially thank you to people for watching, because this is a great way for people to pose their questions about what will be one of the most groundbreaking sort of projects in Victoria ever. due for completion 2025, going to completely change the way we get across the city. If you have any questions, feel free to still post them in our comments section on our Facebook page. They will get answered by our digital team. Go to bigbuild.vic.gov.au if you want to find out about broader projects across across Victoria, and metrotunnel.vic.gov.au. That's metrotunnel.vic.gov.au about Metro Tunnel specific. Again, thank you very much, Paul Thomas. Thank you very much for viewing. Leave any suggestions about what you'd like to see in future Q&As. And last but definitely not least, thank you very much to our digital team who have made this possible. There's a lot of work that goes into something like this to pull it off. Not always visible to you at home, but we've had our digital team really working hard on this. So collective slap on the back for them. Thank you, Paul Thomas.
Thank
Goodbye,
you.
everybody.
Thank you. Bye-bye.